What time is it? It's science time!
Science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Lila is our notebook navigator, Alfred is our experiment expert, Riley is our dynamite demonstrator, and London is our research wrangler. Working with my team is the best and makes learning so much fun. Actually, you should join us. Today, we're doing kitchen science. What time is it? It's science time! Welcome back to another episode of DIY Science Time. I'm Mr. C, and today I'm excited to have you here as part of our science crew. We're talking kitchen science and doing some of my favorite science experiments right here in my kitchen. In fact, look at this egg. I've got an egg right here, and I'm going to place it into this vinegar. What I love about this experiment is it takes two things, an eggshell and vinegar, to create something new. You can already see that there are lots and lots of bubbles being produced. That's carbon dioxide. Now, if we leave that there for an entire week, 7 days, we get something that looks like this. Isn't that awesome? That is, what is this? Oh, it's so strong. The vinegar is so strong. But look at this. It's an egg. It doesn't even feel like an egg anymore. The shell's not hard. It feels rubbery. I wonder if it can bounce. Oh! It did not bounce. Science fail. That was not supposed to happen, but that's okay. It just means we have to try the experiment again to see if we can change a variable, maybe the length that we left the egg in the vinegar, or it needs to be in there longer, or the type of egg, or maybe a different vinegar. These are just things that we can do to see if we can figure it out next time. Anyway, let's go to our next experiments. We need some materials. Alfred, what do you got for us today?
Mr. C is cooking up some fun in the kitchen today, and you'll need a few materials to follow along at home. You'll need measuring spoons, instant yeast packets, 3% and 6% hydrogen peroxide, dish soap, empty water bottles, food coloring, and most importantly, our science notebook!
A science notebook is a tool that every scientist should have, and it gives us a place to record all of our learning. Taking good notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all the data and information we've gathered during our experiments. Plus, it allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information. You can see I've already added a title and a list of materials for today's activity. Our crew is still going to have lots of information to collect and organize as we go through the experiment, so keep your notebook handy. Most importantly, the more you use the science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook yet, download a copy of Mr. C's science notebook from the website.
Ostriches lay the largest bird eggs. Ostrich eggs are about 6 inches in diameter and can weigh up to 3 pounds. How exciting!
All right, this is one of my favorite activities because it takes something like hydrogen peroxide and creates this amazing foam. How does it do it? Well, let's talk science. Hydrogen peroxide is also known as H2O2. That means there are 2 hydrogen atoms and 2 oxygen atoms for each molecule. If we pour this out into a cup, hydrogen peroxide will eventually decompose. It'll turn into water and release one of those oxygen atoms naturally over time. These containers are brown to allow the hydrogen peroxide to last longer. It prevents decomposition. But if we want to make this erupt and turn into elephant toothpaste, we need a catalyst. So what are we going to use? Yeast. It's called a catalyst because it's going to cause it to happen faster. We don't have time to sit here and watch this turn into water and oxygen all day. So we need to use this to make it happen. So let's pour this into our container. And then let's get our yeast set up so that we can pour it in here and have elephant toothpaste. First thing, take, that was water. First thing, take 2 tablespoons of warm water. And then take your yeast pack and pour it in. I'm gonna use the back of my thing here to mix it up. Mix it up. And we're gonna let it sit just for a second. Kind of chunky. Now before we take this and pour it into this, we're gonna take just a little bit of dish soap and add it to our bottle. Shake it up. And now we pour our catalyst into this. Are you ready? Here we go. 3, 2, 1. Oh, wow. That is awesome. Look at that. It's producing all that foam. And you might be saying, where's the foam coming from? Well, that's the actual oxygen being released from the hydrogen peroxide. So we have all this foam being produced. Isn't that amazing? That is so cool. And I can feel it's a little warm. That's because this is an exothermic reaction. It actually produces heat energy as well during this reaction. I wonder what would happen if we changed a variable, like going to 6% hydrogen peroxide versus 3% hydrogen peroxide. I think we should try it. A chemical reaction is a process that involves the rearrangement of the molecular or ionic structure of a substance. That's fancy talk for taking two substances and creating a new substance. We saw a chemical reaction take place with the vinegar as the shell of the egg was transformed from a brittle shell into a new soft rubbery membrane. Hydrogen peroxide is H2O2 and will slowly decompose into H2O and O2. However, by adding the yeast or the catalyst, it speeds up the decomposition and the chemical reaction occurs instantly. The reaction continues to take place until no more reaction is possible. And now we add our catalyst. Oh. 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 Look at that thing go. Oh, that was really cool. So can you see the difference between the 3% and the 6%? We changed that variable. This is totally awesome. Hydrogen peroxide decomposing before our very eyes and capturing the oxygen in bubbles. I don't think it can get any better.
is a single-cell organism that needs food, warmth, and moisture to thrive. When we add warm sugar water to dry yeast, the dormant yeast cells become active. The active yeast feeds on the sugar and produces carbon dioxide gas. The carbon dioxide gas is what makes baked goods rise. Now that's some tasty science.
We already have some great ingredients for some exciting science. I made sure to write down the definition of a chemical reaction and included London's research about yeast and eggs. Based on my observation, the 6% hydrogen peroxide produced more oxygen bubbles than the 3% hydrogen peroxide. I'm also curious to know if adding more of the catalyst would change how much foam is produced. It would also be really interesting to try this reaction with different plastic bottles to see if it would cause the foam to flow differently.
Elephants have the largest teeth on the planet. Each molar can grow up to 12 inches long and weighs more than 8 pounds.
Instead of using the 3% or 6% hydrogen peroxide, I brought along hydrogen peroxide that is 35% proof. What does that mean? It means that it is 10 to 12 times stronger than the hydrogen peroxide that you have at your house. And which means you should not be doing this experiment at home because watching it is just as cool. In fact, we're gonna produce so many oxygen bubbles that I had to cover up my table so that we can make a little bit of mess. For this chemical reaction to occur, we need a catalyst, something to speed it up. So we have a catalyst and it is potassium iodide. It acts just like the yeast that you used at home or that you plan to use at home for the fun at-home family-friendly version. So what we're gonna do is we're gonna put 200 milliliters of hydrogen peroxide, 35% into each of these graduated cylinders. We're gonna add a little bit of soap. Then we're going to introduce our potassium iodide to see what happens. But before I do these 3 graduated cylinders, I actually want to test with this flat bottom flask first. I've actually never done elephant toothpaste in this shape of a container, so I thought tonight would be the night to try something new. Let's get started. So first things first, we're going to introduce and pour in our hydrogen peroxide. And what we need to do now is add a little bit of soap. I'm gonna swish that around. And because I just wanna see what it does, here's some yellow food coloring. Oh yeah. And now we pour this in. We need a countdown. 3, 2, 1. Oh my gosh. Look at that. Oh, and look at all of the heat that's coming off. That's because this is an exothermic reaction. It's producing all sorts of heat. This is very, very warm. We don't want to get our hands in it. But what we want to do now is, that's yellow. It's time to try something just a little more patriotic. So I figured if we do this again, we could introduce red. It'll be kind of yellowish, but white and blue. About 200 milliliters. We're gonna add our food coloring, red, blue, add a little bit of soap. And now, all we need to do is add our catalyst. All right, I gotta pour these fast. Here we go. In 3, 2, 1. Ah!
The next time you have a lemon, try this fun experiment. Take a lemon and roll it on your table to break up those pockets of lemon juice. Cut the lemon in half and add your favorite food coloring. Add a little salt to the top of your lemon. And then pour on some baking soda. If you need to, use a craft stick to push the baking soda down into the lemon. Isn't that awesome? The chemical reaction taking place between the citric acid and baking soda produces a gas, which is captured in the soap bubbles to create lemon bubbles. I wonder if other fruits might work also. Give it a try.
You might not believe it, but seaweed is in your toothpaste. Seaweed acts as a thickening agent that allows toothpaste to be squeezed from its tube.
This is one of my favorite kitchen experiments, and it's such a simple thing to do. We are measuring the power of hydrogen using this red cabbage. That's right, this cabbage is very special because it has a pigment called anthocyanin in it that allows us to use it as an indicator. It's going to help us determine whether or not these things are acids and bases.
Let's do this.
Oh yeah, that is mixed up so well now. But before we actually use it to test, we need to strain out the cabbage so that we have nice, liquidy indicator fluid. That is a strong, strong smell. Woo! That's the smell of science. All right, let's place this up here on the blender. Also, I just want to make a quick note that the red cabbage, I mixed it in with distilled water. So distilled water is pure water. It has a neutral balance. There are no minerals or things in the water like you might find in your tap water. And that's what really gives us the ability to have this really purple, rich purple color. Look at this. Let's pour it out. So the center, we're going to keep it neutral. We're not going to put anything in this, but we are going to test the other ones with these four objects. Well, four items. I have baking soda, some lemon juice, I've got some vinegar, and some toothpaste. So let's start with the vinegar. Oh wow, that turned really pink. Look at that. Let's try the lemon juice. That's also super pink. All right, we're gonna skip this one. This is our neutral. This is baking soda. Oh wow, the baking soda turned it blue. And here I have some toothpaste. Now the toothpaste is a little bit blue, so I'm not sure how this is gonna work. I also have a spoon. Let's mix this up. So, okay, it's turning like a blue purplish. Some of that might be because of the toothpaste, but I would say that it's a different blue than what the toothpaste was. So this actually turned blue as well. So you might be asking yourself, what are we looking at? Well, technically this is like a pH scale, the power of hydrogen. This is neutral, it has a pH of 7. The side over here that's pink, that's more acidic. So that has a pH from 0 to 6.9. Then we have our neutral in the center, 7, and this is 7.1 up to 14. That's the range. What a fun way to test whether things are acidic or basic in your house. What other things could you test? Have some fun with your parents, check out what you've got in your house, and then use the red cabbage as an indicator.
Baking soda is a base, and vinegar is a weak acid. When these two things are mixed together, a chemical reaction takes place to produce water and carbon dioxide. This reaction creates lots of bubbles and expands. If you're careful, you can capture the released carbon dioxide to inflate balloons.
That's awesome.
Someone say it's time to party. Whoop whoop.
Look at all the bubbles.
In 1956, food chemist William A. Mitchell invented Pop Rocks. This candy is unique because it's basically sugar gasified with carbon dioxide. When you eat the candy rocks, the moisture from your mouth dissolves the sugar and releases the gas. You can hear and feel the crackling.
Yep. I'll go ahead and confirm that dentist appointment for you, Mr. C.
I never knew that kitchen signs could be so colorful and fun. Bouncing eggs, colorful lemon bubbles, and even using red cabbage as an indicator was a great way to investigate chemical reactions. Our crew did an amazing job today, but I'm still really curious to see how high we can get those vinegar eggs to bounce. What if we use an ostrich egg? That'd be one exciting, extravagant experiment.
Oh my gosh, what an amazing day of learning today, right here in our kitchen. We've been taking lots of notes, so we've been busy with that, and most importantly, there are still tons of things that we can do in our kitchen to keep exploring with kitchen science. You know that baking soda that we use for this chemical reaction? I'm thinking I need to bust out and make some chocolate chip cookies with one of our favorite family recipes. I think that's what I'm doing right after this episode, because learning keeps going. It doesn't stop here with what we did today. And I have another egg, and I want to see if it bounces. Before I try to bounce it, I want to encourage you to keep learning, keep having fun, keep exploring, and remember, science is wherever you are. Fingers crossed.
It's science
It
time.
bounced. I can see the egg yolk rolling around.
It's science time.
Bye. Oh my gosh, kids. Oh my gosh. Oh my gosh. Kitchen science fails. Alfred, what materials are we gonna need today, dude?
It's so much fun. Learning fun for everyone. Everyone. It's science time. Yes, yeah, that's
Science fail. That was not supposed to happen.
It's science time. Every day.
Red cabbage, where you at? All right, here we go.